Hi, the purpose of this video is going to be to talk about what do distance versus time graphs, distance x, time t, look like for motion where there's a change in velocity and acceleration. So up to this point in the year, we've learned a couple different things. First, that velocity is the slope on a distance time graph. And if you have a positive slope, that means a positive velocity. Also, we've learned that if you have a negative slope, that means a negative velocity. We've also learned that positive and negative are fundamentally directions. One direction is positive, one direction is negative, and then we have to specify that at the beginning so that we actually know what we're talking about. So before I move at all, I'm going to say that this place right here where I'm standing, I'm going to call that distance 0, the origin of my graph. Furthermore, I'm going to say going this way is positive. It doesn't have to be. That's just a choice I'm making. So whenever I'm moving in that direction, my distance time graph is going to have a positive slope. Conversely, when I'm going in this direction, it will have a negative slope. So as you watch these motions, I want you to think about where am I starting? Am I starting at 0? Am I starting negative? Am I starting positive? That's going to tell you what the intercept of each of these graphs is. Then, I want you to also ask yourself, am I speeding up or slowing down? Whether I'm going positive or negative, if I'm speeding up, I'm going to be getting steeper. If I'm slowing down, I'm going to be getting shallower. So this first one is going to be starting at the origin. I'm starting here. I'm going to start slow. I'm going to move in the positive direction. And I'm going to get faster and faster. So what I'd like you to do is predict what shape that graph's going to have. Here I go. Okay? So what did that look like? Well, I'm starting at the origin, so that means for this graph, my first data point's going to be here. And since it's slow, I'm going to have a shallow slope. But as I go faster and faster, the slope gets more and more and more. So that first motion looks something like that. Let's try another one. I'm going to start here, I'm going to start fast, but I'm going to slow down. And I'm going to move in the positive direction. So think about what that might look like. So, still at the origin, but now I'm starting off steep. But I'm getting less steep. Eventually I'm horizontal. This isn't an asymptote. I got to my last point. Something like that. I'll do one where I start over here. So now I'm going to be moving in the negative direction. And I'll start fast and I'll slow down. So, in that case, I started not at the origin, but at a positive position. But all my slopes will be negative since I was going in the negative direction. So I started fast. That's a steep negative slope. And it's going to get shallower. And I went past the origin, so I do cross the axis. Okay, last one. Start slow and speed up. So what will that look like? Again, starting at a positive position with a shallow slope, but getting steeper and steeper. So something like that. It's expected that with some practice, you can look at a graph and visualize in your head what the motion is. Again, where did I start? That's the intercept. What direction am I going? That's the difference between positive slopes and negative slopes. And how fast am I going? That's the difference between steep and shallow.